Alright, so in this video we're going to be going over problem set 2. So let's start with number 1. Circle all the following that are aromatic. Note lone pairs on heteroatoms have not been shown. Okay, so let's start by going with answer choice A. We can automatically rule out that this is not aromatic because it is not cyclic. Alright, let's go with answer choice B. We have a cyclic structure here, sp2 carbon here, sp2 carbon here, as well as an sp2 carbon here, and we have an odd number pair of electrons, which is just 1, so this in this case would be aromatic. Let's look at choice C. It's the exact same thing as choice B, but with an extra pair of lone pairs here, which makes it an even number of lone pairs, which would make this anti-aromatic. We can rule out C. Let's look at D. It is a cyclic structure, which is a good start. We have 1, 2, 3 odd pair of pi electrons, but we have this right here. This carbon is going to be sp3 hybridized, so this is not going to be an answer choice. Let's look at answer choice E. We have a cyclic structure. We have 1, 2, 3, an odd number pair of electrons, as well as all of these carbons being sp2 hybridized. So this is going to be aromatic. And let's look at answer choice F. We have a cyclic structure here. We have one pair of electrons here, another pair of electrons, which is 2 pairs. So we might think that it is anti-aromatic, but in this case, there is a pair of lone pairs here that are not shown, which will make 3. So this will be aromatic. Awesome. Let's go with question number 2. Name the following aromatic compounds using IUPAC system naming and substitutive naming when appropriate. So these are just some of the parent chains that you're going to have to memorize. So how I like to approach this question is by looking at the benzene and seeing where the parent main chain is. I like to think of it as. So in this case, for question number A, the main chain is going to be aniline. So what I would do is I would circle aniline here, and we would name based off of that. So this carbon here going on the NH2 is carbon number 1. Carbon number 2 is going to be here, and carbon number 3 is going to be here. If we go the opposite way, it's going to be 1, 2, 3, 4, 5, which is a higher naming scheme, which is unfavorable. So let's name it here. This is going to be 3 nitro aniline. And a very, very common mistake is oftentimes people will think that NO2 is going to be a parent chain, but it actually isn't. It's not going to be a parent chain, so do keep that in mind. So let's look at question number B now, or letter B now. We have our parent chain here, which is going to be phenol, so we're going to circle phenol. Then we're going to start naming from this OH carbon. And if you find out either way we go, it's going to follow a 2, 3, 4, 5, 6. If we go the other way, it's going to be 1, 2, 3, 4, 5, 6. So either way we go, it's going to be a 2, 6 naming scheme, so it doesn't really matter. So we're going to go 2, 6. Remember, there's 2 bromines, so we're going to slap a di in front. Di, bromo, phenol. Alright, let's go with question letter C now. Let's try to find the main parent chain. So in this case, there are actually 2. This is going to be the CHO as well as the OH. And in this case, the CHO, which is the aldehyde, takes priority. So that is going to be our parent chain. So let's start naming here. Once we have a parent chain, all the other side chains are going to drop down to be substituents, and they're going to functionally be the same power level, priority level. So sometimes people will want to go to the right, 1, 2, 3, because they think that OH is higher on the list than Cl for priority, which is technically true, but since we have a benzaldehyde here already, they're going to functionally be the same, and we're going to name based on alphabetic. So we're going to go to the left. 1, 2, 3, 4, 5, 6. So our final name is going to be 3 chloro 5 And the prefix for OH is going to be hydroxy, not hydroxyl, it's hydroxy. And then the parent chain is benzaldehyde. Perfect. So let's look at letter D now. We're given a benzene, and in this case, there actually isn't a parent chain. So we're going to name based on numbers. Remember that the order matters first, and then alphabetics matter. So we don't want to start with the bromine. We can just start with either one of the chlorines and go from there. I'm just going to start from the one up here. 1. We're going to name this way. 2, 3, 4, 5, 6. So this is going to end up being 2 bromo because of alphabetics. And remember, there's 2 chlorines. So we're going to slap a di. 2 bromo, 1, 3, di, chloro, and it's just going to be regular old benzene. Awesome. Now next, for letter E, we have 2 parent chains. We have this phenol right here and this aniline. And in this case, the phenol is going to take priority. So we're going to start naming here. I'll erase the aniline. Phenol is going to take priority here. 1, and then we're going to name, doesn't really matter which way we go because it's going to be 1, 4 no matter what. They're both pair substituted. 1, 2, 3, 4. So we have 4. The prefix for this one is going to be amino, and then it's just phenol. Awesome. So now let's look at letter F. This, we're going to see here, the main parent chain is going to be right here. This is a benzaldehyde. Sorry, benzoic acid, my bad. This is a carboxylic acid group, so this is benzoic acid. We're going to start the naming scheme at that carbon right there. So we could go either to the left or to the right. It's going to be 1, 2, 3, 4, 5, 6. So it's going to be 3, 4, 5 naming scheme if we go that way. This way it's going to be 1, 2, 3, 4, 5, 6. It's going to be 3, 4, 5 as well. So now we're going to look at alphabetics. So in this case, the tiebreaker is going to be between bromine and chlorine, and bromine wins because it's first. So we're going to go to the right. So let's start by naming 3 bromo, and then it's going to go 5 chloro, and then the 4, that's going to be methyl. We don't want any carbo or whatever it might be. 4 methyl, and the parent chain is going to be benzoic, and remember there is a space between this, benzoic acid. It's always going to be a space between benzoic acid. Awesome. Lastly, let's look at question G. So oftentimes we want to start off with naming the benzene, but we're going to quickly find out we're going to get into a lot of trouble here. It's going to be very difficult to name the benzene, and we have these 2 OH groups coming off of this carbon here. So we're going to name this chain as our longest parent chain. 2, 3, 4, 5 carbons here. Going to go ahead and highlight that. And we have our groups. We have a side chain benzene, which if you guys remember, it's going to be called phenyl. And then we have our 2 OHs, which is going to end up being our end of the parent chain. So we have 4. The benzene side chain is going to be phenyl. Not to be confused with phenol. There's going to be a Y here, phenyl. And then we have a 5 carbon parent chain, pentan. But remember, there are 2 OHs coming off here, which means that the ending is going to be diol. And if we have a diol, there's going to be a consonant there. So I'm just going to write it out here. It's going to end in diol. Because this D is a consonant, we want to keep the E in pentane. So it's going to be pentane diol instead of pentanediol. So both of these OHs are coming off of carbon number 1. So it's going to be pentane 1,1-diol. All right. Thank you.